This is Scott from KIG. It is March 16th, 2021, and we're going to do a brief runoff and overview demo of this 2016 10-ton PRM 460 volt air-cooled indoor process chiller. And we're getting, this one is sold. We're getting it ready to ship to its new home in the next day or two. In this case here, we have an insulated stainless tank. We're running it with some glycol today. This is our process pump, which actually draws from the tank, goes out to the process, and that's 1 1/4 NPT fittings there. In this case here, we have a pressure gauge, a flow meter, and a little test loop, and it returns back to the top section here, the top fitting, which is 1 1/4 inch NPT also. This here is your fill port. That's where you should fill it with water or glycol. If you're going to run straight water, we always recommend running some glycol. If you're going to run straight water, I would not run the unit below 8 or 9C. The controller allows us just to run down to 3C, which is about 38 or 39 Fahrenheit, give or take. But you really shouldn't run below about 48 Fahrenheit if you're just running straight water, because you could get freeze-up conditions inside this brazed plate evaporator here. That's our 10 horsepower Copeland scroll compressor. When you do start the unit up, you turn the water pump button on first, which we have had on for a while. And our tank is, we currently have the set point at 26C. Our tank is heated up to 22.8C just from the heat of the pump running on its own. When you first put power to the chiller, and that is our electrical area there, if you do have the wrong phase, it is a 460 volt 3-phase unit, you will get the error light that comes on that does say wrong phase. If that is the case, you take any of the 2 incoming power leads and you swap them. The compressor and the glycol pump are synchronized themselves, so it's the main incoming power that you would swap until you don't have the wrong phase error button. We're going to go ahead and turn the compressor power light on. To change the set point, it's very easy. We press set, then you see the lower set point number flashing. Just going to bring it down, and today we're going to run it to, let's say, 6C. Okay, going to press set again. Start chilling. In this case here, because we had the power on and the pump running, there was no delay. On a fresh startup, there will be a 3-minute delay for the compressor to start to let things stabilize. We've run it for several days, gone through a few things, touched up the top panel, had some scratches on it, repainted it. This is our low pressure refrigeration gauge. This is our high pressure refrigeration gauge. We've checked the charge, we've checked the superheat, and it's a strong running, good industrial indoor chiller. It's not weatherproof to run outdoors. As you can see, we don't have much load. It's just the volume of the glycol in our tank and loop that's going to chill down fairly quickly here. The unit does have its own internal adjustable manual flow bypass. You can see that basically looks like a boiler drain knob that connects the, sorry about the camera there, connects the supply to the return. We're going to ship that cracked open a turn or two. Unless you have a bypass in your loop, you should not have that fully closed. But in some cases, you may have to open that up a little bit. A symptom would be, if you're not bypassing enough and you have too much restrictions on your process, is if we're restricting too much flow back to the heat exchanger here, it would go into low pressure alarm, and that can be related to not enough flow, in which case we would open up that valve there another half turn and see how it ran. This is the proven R407C refrigerant, I think I mentioned. If we do go into low pressure alarm, which is usually due to either running too cold of a temperature for your fluid, like if you're running 4 or 5C with straight water, you'll get refrigerant pressure too low. And then if you have dirty condenser fans, or you're running in an ambient condition that's way too hot, then you could get a high pressure trip. There's also a pump overload indicator light. If your pump is over amping because there's not enough restriction in the loop, because a pump does like back pressure, then your pump contactor would need to be reset there, and it'd trip out on the pump overload. The other contactors there are for the compressor and the fan. That's your adjustable pressure switch there. Kind of tough to see. Trip out on a pressure error, you would go to that adjustable pressure switch I just showed you, and it would have a reset button on it. And then ultimately would need to diagnose the unit and or give us a call. We walk you through some things. We do have the side covers. This unit has a little mouse hole that was cut out in it. It's tough to see, but that is a metal panel there. We do see this sometimes. It's actually kind of neat. There is the option, an additional fitting on the side of the tank if you wanted to steal some additional flow for another process through another pump or a separate loop, or tie it into a second chiller, frankly, which can be done if you do it correctly. So we met our 6C set point. The unit shut off. There'll be a little bit of drift going a little colder, and the differential built into the controller is 1C. So the compressor would turn back on once we get up to 7C. But the pump always runs, of course. So that's it for this one. This is Scott from KIG. Our website is kigsales.com. Thank you.